Today we are going to discuss about this problem that in the previous class we have done the concept of effective stress. You can check my video, and so here we will be doing a problem about the effective stress. So first of all, it's a problem of IS 1995. So let's start it. Okay, so total stress we have to find out. So what is told here, that if the saturated soil has density of 2.1 ton per meter cube, then the total stress and effective stress of this given soil at depth of 4 meter will be. So you can see the picture, I have already drawn it. So it is totally given, so we have to find out the effective stress and total stress of this saturated soil. Okay, so for this total stress, sigma, we know that gamma into H, right? So gamma here it is saturated unit weight, so that is 2.1 into H, that is 4 meter, that is 4, that is ton per meter cube into meter, so it will be ton per meter square. So it is coming about 8.4 ton per meter square. Now we have to find out the effective stress. So for finding out the effective stress, we have to first find out the pore water pressure. So pore water pressure, that is U is, we know that gamma W into H, that is just the hydrostatic pressure within the soil. So gamma W is equal to 1, because we know that the unit weight of the water, that is 1 gram per semi cube. So if we convert it to ton per meter cube, it is same. So this is 1 and H will be 4 meter. So 1 into 4, again ton per meter square. So this is 4 ton per meter square. So this is our pore water pressure. So we know that for the effective stress, will be sigma dash is equal to sigma minus U. So what we will be doing, that from the total stress we will be subtracting the pore water pressure, then we will be getting the effective stress. So here it is 8.4 minus 4, that is ton per meter square. Always keep in mind the unit, because in exam they will change the unit, so always keep in mind what unit you are writing. So then it is coming 4.4 ton per meter square. Okay, and this is the answer. So our answer is total stress is 8.4 per ton per meter square, and effective stress is 4.4 ton per meter square. Let's see this problem. So this is the next problem we are having for the effective stress concept. So first we will be drawing the effective stress diagram for this given situation. So first read the problem, that is the draw the effective stress pressure diagram for a saturated soil mass of depth Z submerged under water of height Z1 above its top, and it is given that gamma submerged equals to gamma dash. So what is told here, that the soil is submerged and the we have to find out the effective stress at this point, the depth of Z from the soil bed level, and there is water above the soil bed level whose height is Z1. So let's find the total stress first. So total stress Ts, that we know that sigma is equals to the total weight or total load that is acting on this soil system. So total load, what is the first one? That is the weight of the soil, that is the first load, and the second load is the weight of the water. Okay, so we, and also it is told that the, as the soil is saturated, so we will be taking the gamma saturated density, or we will be taking the density of the soil as gamma sat. So gamma sat it multiplies z, okay, plus this is the first weight of the soil, self weight of the soil, and this is the water load, that is gamma w into z1. So because the gamma w is the water unit weight, okay, then we have to find out the pore water pressure, that is u is equal to, so for the pore water pressure we know that it is just the hydrostatic pressure. So the that is that the total water level is gamma w into z1 gamma w into z. This is the pore water pressure, because the pressure within the soil, the pressure of water in the pore of soil, that is pore water pressure. So gamma w into z. So after that, effective stress, sigma dash, look here, there is another catch is there, that this is the pore water pressure plus this, what is the situation, it is the mistake the people will be doing, that we have only z depth, so we will be taking the only the this much height of the for the pore water pressure, but it is not, because the water level is here, water surface level is here, so this pressure will be transferred to the here. So we have to add this much pressure of the water to this pore water pressure. So it will be plus gamma w into z1. So this is you have to carefully watch that for this height of water you have to take for the pore water pressure. So now we will be just subtracting from the total stress of from the total stress of pore water pressure, that is sigma minus u. So sigma here, that is gamma sat into z plus gamma w into z1 minus gamma w into z minus gamma w into z1. So what we are getting, that this one and this one is getting cancelled. So it's remaining that gamma sat into z minus gamma w into z, and we know that gamma sat minus gamma w, that is the submerged unit weight of the soil. So here it is given, that is gamma dash, so it will be gamma dashed into z. So this is our effective stress. Now let's draw the diagram. Okay, just I am just erasing this. Just let's draw the diagram. So now we will be seeing this value of effective stress here. So at the point A, so the sigma bar at A, that is the total stress minus pore water pressure. So this is the total stress, that is gamma W into Z1 minus, okay, minus this is the pore water pressure. Just actually you can see that there is at the top level there is no soil, so there will be no contact of soil solid particles. So from there also you can write it's 0, like conceptually you can think. And if you want to do mathematically also, just take this point, and this is the total stress on this point because of this water of height Z1, that is gamma W into Z1 minus that is pore water pressure, that is if you just take imaginary soil on this on here, so that will be gamma W into Z1. Or you can think like that soil is here, so just below this soil bed level if you take, so the pore water pressure will be gamma W into Z1, like that also you can think. So it is coming out 0. So let's draw the diagram of the effective stress. Just take the bed level here. Okay, so this is the Z1, and this is the Z. So at this point this is 0, and here at the point of Z, that is gamma A, like just write this point is A and this point is B, point is B, okay. So just see, so here is the value is 0 at point A, effective stress is 0, but at point B the effective stress is gamma dash into Z. So what we can see that it's a linear variation across the Z, so it will be a straight line. So the variation will be like that. So this is gamma dash into Z, and this is the diagram of effective stress for this problem, okay.